Hello viewers, welcome back to the course on scientific computing using Matlab. So, now we will continue with the previous topics we have started with the interpolation. So, today we will discuss that about the how we can make the finite difference table to approximate the value of the function at any x required or for any x in the given interval. So, today is the lecture number 36. Now, today we will discuss about the finite difference table. So, as we know that I have, so this is my x axis and this is y axis, and I have some data that is distributed equally spaced for the given interval. So, suppose this is my x0, x1, x2, x3, x4, x5. So, let us take that there are total number of 6 mesh points or the nodal points, and at this nodal points we have the value of the function that is given to us is this one, then this, maybe this value, then this value and then this value. So, this value is given to me. So, I will call this point as, so this point is x0, y0. So, this is the y0 point, then this is my x1, y1, x2, y2, then x3, y3, x4, y4, x5, y5. So, all these points are given to us. Now, somebody asked me that I want to approximate the value at this point. So, that is, suppose I take the x, or somebody asked me I want to find the approximate the value of the given function for some x that is lying here or some x in between. So, everything depends upon that where you want to approximate the value of the function for a given x will make the finite difference table. Now, and we also know that if I want to interpolate this function with a polynomial, then my polynomial will be like this one. It is passing so starting from here, it will go like this because it should be passed from all the given data points. So, it should be like this, then this and then this value. So, that is my approximated polynomial, and that we represent by Px. And what is the value, what is the function here? So, function we do not know, but let these points are satisfied by some function. So, maybe let I take that this function is my function is like this one, then going this way and then going this. So, let this is my function. So, that function we do not know, but we are taking that there is some function and the points are the few values of the function at the given value of these nodal points. So, that data is given to me. Now, based on these data points I want to approximate a polynomial. So, this Px is a polynomial that is giving me the interpolating polynomial passing through all these data points. Now, suppose I want to find the value of the function at this x. So, at this x, if you see the actual value may be different from the approximate value. So, that maybe I can call it that this is the error, or maybe I want to find the value of the for this x. So, at this x this may be a approximated value and this may be the exact value. So, that is the error. So, this error everywhere you will see that if I want to approximate the value at any x in between, there is some error involved in this case. So, that we also discuss today. So, let us make the finite difference table. So, in the finite difference table suppose, so this is given to me. So, I start with the table. So, this is my indexing. So, that is 0, 1, 2, 3, 4, 5, 6. So, we have the value up to 5. So, I will take only up to 5. Now, at this I have the x coordinates that is given to me. So, this is x0, x1, x2, x3, x4, x5, and these are the value of the y is given at x naught. So, let us take this one. So, I just for the time being I just take x naught is equal to 1.2, 1.4, maybe 1.6, 1.8, 1.2, and this is I can take 2.2. So, in this case maybe I can, because I have a dealing with the 6 values. So, this table will be very large. So, I will just remove one value also. So, you can remove the value just based on that the large number of values, the bigger this table will be. So, I will take only 5 values, and this value I am taking this, and suppose the value at given to this is given like this one, 1.0627. So, this is value given to me 1.1187, 1.1696, 1.2164 and 1.2599. So, this value is given to me. Now, based on this one I will try to find out the differences. So, I will first find out first difference. So, first difference, you know that I will take this value minus this value. So, this minus this if I find, then it is giving me 0.0560. So, 87 minus 2760 and 11 minus 6 is 5. So, this value. So, this value I am writing here, the in between this. So, that shows that this value is the difference of this minus this. Now, I will find the next difference. So, the next difference will be 0.0509. Then the next value I will write here. So, 0.0468, and the next value is 0.0435. So, that is the first difference I have taken. This minus this, this minus this, this minus this, and this minus this. So, this is the first difference. Then I will write the second difference. So, you know that from the we started with the 5 value. For the first difference will be the only 4 values, and the second difference will be difference of this value. So, this minus this, that will be the second difference, and if I take this value, this will be minus 0.0051. So, it is the smaller than this one. So, that is why negative sign is coming, and 51. So, it is coming. Then next will be minus 0.0041, and the next value will be minus 0.0033. Okay, so, that is the second difference, and we will now left with only 3 values. Then I will take the third difference. Now, we also know that we have a 5 values. So, in the previous lecture we have discussed that if I go with this 5 value, and so the fourth difference will be a constant value. So, that we already know from the previous lecture. Now, the third difference will be this minus this. So, if you take this one, it will be 0.0010, and this will be 0.0008, and the fourth difference I take. So, this will be the difference of this. So, it will be minus 0.0002. So, now from here you can see that they are the 5 values, and the fourth difference is a constant value. So, if I take the fifth difference, then it will be 0. that we have discussed in the previous lecture. Now, from here you can see that, so this is my, so this value is basically, if you see, this is y0, this is y1, y2, y3 and y4. Now, what about forward operator of y0? So, this will be y1 minus y0. So, this is y1 minus y0. So, from here I can say that this is forward operator y0. What about forward operator of second forward operator of y0? So, this will be again, I am taking the 2 times of this. So, y0. So, this I can write y1 minus y0, and from here I can write y1 minus forward operator, and using this, so from here I can say that I have taken this value minus this value, and what is this? This value minus this value. So, from here you can see that this is the second order finite difference, forward finite difference operator, and similar way this value is del cube y0, and this is del cube del 4 y0. So, this the value on the top, they are giving me the first forward operator, forward difference, second forward difference, third forward difference and the fourth forward difference. Now, from here I can see, now what about these values? So, this is my y4. Now, what about this value? So, this value is giving me this minus this. So, I want to check what will happen. Now, I want to apply the backward. So, backward y4. So, it will be y4 minus y3, because it is going just one backward. So, I want to find this value. So, this will be this minus this. So, this is the value. So, I can say that this is the first order backward difference. What about this one? The same way, this minus this. So, this is the second order backward difference. This is the third order backward difference, and this is the fourth order backward difference. So, now if you see from here, it is the downward going, this is the forward differences, and this is going up. So, that is the, so this is going up. So, this is the backward differencing, and this is going downward. So, this is the forward differencing. The same way I can define the central differencing. So, from here you just see that central differencing means I just take the value that is in the center. So, let us choose y2. Now, if you see from there, this is my y2. Now, based on this one, I will choose this value and this value. So, this is my y2. Now, from here I can say that this value is, now I want to find delta y2. So, what is the delta y2? It will go y2 minus half minus y2 plus half. So, it will be y3 by 2 minus y5 by 2. So, this value is, I call it delta 3 by 2 and this is delta y5 by 2 and so on. So, the next will be delta square. So, this value, if I choose this one, so this will be this minus this. So, I can this is delta y2 and so on. So, now I can choose these two values based on this, and this value will be this minus this. So, this is delta square, and you will see that this becomes delta cube y2. So, now the same value is either represented by the forward fourth order difference, backward fourth order difference, or the central y2 third order difference. So, from here you can see this will be fourth order. So, from here I can write this is delta 4 y2. So, first order difference, second order, third order and fourth order. So, from here I can say that based on this one, this fourth order y naught is equal to fourth order y 4 and it is equal to delta 4 y 2. So, all value is equal to minus of 0.0002. So, that is also the verification that if we have the data 5 data points, then the fourth difference will be a constant value and the fifth difference will be 0. So, that is also one of the verification we can do. So, this is the basically we can make the difference table whenever the some data values are given to us, and based on these values we want to find approximate the value at any x. So, in this case what we will do now, suppose I want to find based on these values I want to approximate. So, we would like to find approximate value of y at x is equal to, say I just want to choose at x is equal to 1.3. So, I want to find the value in between, that if I put the x is equal to 1.3, what will the value of y. So, this one I want to approximate, or in other sense I can say that I want to find the value y at x is equal to maybe 1 point in between I want to find. So, maybe I want to find at 1.65, or I want to find what is the value of y at x is equal to 1.97. So, I want to approximate the values at these different values of x, and if you see from this value of x lies. So, 1.3 is lying here, 1.65 is lying here and 1.97 is lying here. So, it is up to me, it is depend upon that where the value of the x is lying. So, from here I can say that x is lying in the upper top of the table, another value of the x is lying in the central, or another one is lying in the bottom. So, based on that where the value of this x lies, we can find the different methods to approximate or to find the interpolating polynomial. So, that is the way we can make the finite difference table. So, next thing, so after this we want to find out that what will happen if there is some error introduced in the values of the table. So, the propagation of error in a difference table. So, now I want to find out that how the errors propagate in the difference table. So, let I have the difference table like this one. Suppose I have this is the x and this is y. So, let us take this is x naught, x1, x2, x3, x4, x5, x6, x7. So, let us take the 8 values. So, this is y0, y7. So, let us take that at in between there is some error introduced. So, plus epsilon is the error. Now, I take, So, let us take the first difference. So, first difference, if you see, maybe I can now write in the forward differencing. So, I can write it here, this will be equal to y naught, this will be equal to y 1, this will be equal to this minus this. So, I will get y 3 plus epsilon minus y 2. So, that is equal to y 3 minus y 2. So, del y 2 plus epsilon. Next value will be y 4 minus this. So, from here I can write that y 4 minus this. So, minus epsilon will be there. So, here I can write del. So, it is y 2, it is y 3 minus epsilon. Then del y 4, del y 5 and del y 6. So, here I am using the forward differencing operator. So, this is the value. Now, this is in the first difference, this error propagates and it appears at the two places, plus epsilon and minus epsilon. Now, let us take the second difference. So, in the second difference, if you see, this minus this will be del square y naught. So, this minus this will be del square y 1 plus epsilon, this minus this. This minus this will be del square y 2, this minus this. So, it will be minus 2 epsilon, and then it will be del square. So, del y 3 plus epsilon. From here del square y 4 and this will be del square y 5. Because we are taking the forward. So, in the forward, if you move with the higher operator, higher difference value, then these values keep reducing. So, y 7 has reduced, has eliminated. Now, after that del y 6 has eliminated. So, in this way we can go. I take the third difference. So, in the third difference, this minus this. So, it will be del square y naught plus epsilon. This minus this will be del square y 1 minus 3 epsilon. Y 2, this minus this plus 3 epsilon. This minus this will be del square, del cube, sorry. So, this is cube. So, y 2 and then y 3, this minus this. So, it will be minus epsilon and then y 4. So, that value is given. So, if you see from here, the next will be, so here you can see that the error has been distributed, or error is spreading in the two places here. So, in the two places it is coming, the error is coming here. In the second difference, error is spreading at 3 places, then error is spreading at the 4th places. So, from here you can see that if I take the next one, the 4th difference. So, this will be, in this case, this minus this. So, that will be del 4 y naught, this minus this. So, it will be minus 4 epsilon. This minus this will be del 4 y 1, this minus this. So, it will be 6 epsilon, del 4 y 2. So, this minus this, it will be minus 4 epsilon, this minus this, it will be del 4 y 3. So, this minus this plus epsilon, like this one. So, from here you can see that the error propagates as we go for the higher differences, and the pattern, if you see, the pattern of the error is like this one. So, here is the pattern is like this one, here is the pattern is like this one, and so on. It means that I can see from here that the errors grow with higher order differences in the binomial fashion. In the binomial fashion. So, in the binomial fashion means, if you see from here, the error is coming epsilon and minus epsilon, then it is coming epsilon minus 2 epsilon epsilon, then the third one is epsilon minus 3 epsilon 3 epsilon, and then minus epsilon. So, like this one it is coming. So, from here you can see that this one I can write as epsilon, and this is 1 minus 1. This one I can write as, taking epsilon out, so it will be 1 minus 2 1. So, if you see from here, it is a square plus b square minus 2ab, a minus b. From here it is epsilon. So, 1 minus 3 plus 3 minus 1. So, it is a cube plus b cube minus 3ab a square b minus plus 3ab square. So, this is also, if I take this one, I can write as 1 minus 1 power cube. This I can write as a 1 minus 1 square. This I can write as a 1 minus 1. So, like this one. So, it is a binomial fashion, the error is growing, and it grows with the, as we take the higher order differences. So, from here also that I can write that evidently the sum of errors in any column comes to 0. So, if I choose any column and add the error, so plus epsilon minus epsilon 0, plus epsilon minus 2 epsilon, so that will be 0. So, this will be 0. So, if I choose any column and add all the errors, so that comes to 0. So, that is the one of the another factor of another properties of the finite difference table. And the second one is errors are distributed symmetrically about the incorrect value. So, incorrect value means, like this one I have taken y3 in our case. So, errors are distributed symmetrically about the incorrect value, above and below it. So, from here also we can see that the errors are distributed one above, one below, then one more above, one more below. So, it is distributed symmetrically in the above way, in the above and then the below. So, that is also one of the characteristics of the errors in the finite difference table. So, I should stop here. So, today we have discussed about the how for the given data how we can make the finite difference table, and in the next lecture we will discuss that how the finite difference table is used to approximate a value. So, thanks for watching, thanks very much.